Okay, this is section 7.4, and we're talking about these things called nth roots. A lot of this is review from Algebra 1, so I'm going to make this as short and simple as possible, this section. This is just to give you a refresher of how to simplify roots that are higher than square roots by hand. There's just a couple little things that we have to talk about, especially when we're dealing with variables occasionally that will pop up. So let's just go with a little bit of terminology first. So nth roots. The idea of an nth root here is your definition. Okay? And what we basically are saying is, if a to the n power equals b, then we say that a is the nth root of b. And then I have an example here in this next bullet. So if you look, 2 to the 5th is 32. So we would say that 2 is the 5th root of 32. And the way we write this is right here. And this should be pretty familiar to you. Let me just remind you of some different parts of this notation. The 5 is referred to as the index, because it's telling us we're taking the 5th root. The actual symbol here is not a division sign, but it is referred to as a radical. And then the 32 is called the radicand, R-A-D-I-C-A-N-D, in case you're having a little bit of difficulty with my handwriting. Okay, radicand. And then the 2 is the root. Okay, 2 is the 5th root of 32. Now, a little interesting thing that your book notes, and this is important, you may not have talked about this in Algebra 1, is this idea of a principal root. Okay? When you're dealing with an even index, remember that you can have both a positive and a negative root. I mean, think about it. The square root of 4 is 2, but it can also be negative 2, because negative 2 squared also gets you 4. All right? We call the positive 2 the principal root of 4. It's the one your calculator would give you. That's a good way to look at it as well. All right? But technically, negative 2 is the square root of 4. It's why when we did quadratics in the last couple chapters, we had to use the plus or minus symbol when we took square roots. Okay? And that's why your calculator doesn't do plus and minus, because it's only trained to work with principal roots. So there's a little bit of some background of how your calculator works. All right, let's take some roots. So these are 3 separate problems here. I'll break them up so you can see that. All right, so the square root of 16x to the 6th. So we'll start by looking at just the square root of 16. That's 4. The square root of x to the 6th. All right, well, anytime you're dealing with a power inside a radical, the fastest way to do that, this is a square root. I always just do the power of the radicand divided by the index, which is 3. So that means 4x cubed is going to be my answer. All right? Let's try another one. Negative square root of y plus 7 to the 16th. All right, again, this is a square root. 16 divided by 2 is 8. So we just have y plus 7 quantity to the 8th power, and then the negative sign from the outside sticks in here. Now let's look at this last one, the square root of negative 9. All right, well, the square root of positive 9 is 3, but the square root of negative 1 is I. So just a little review from chapter 5. The square root of negative 9 is 3i. All right, so there's some basic ones. There's some more examples if you follow along in the note sheet for you to try as well. And you can pause the video and take a look at that. All right, now, here's where it gets interesting. When we deal with roots, sometimes we have to ensure that our answer is non-negative. And when we must do that is if our problem follows this, what we call even, odd rule. So here's what it means. When you're doing an even index or an even root, and your inside power is also even, and the answer you get by taking that root is an odd power, you've got to put an absolute value bar on your answer. All right? And the reason is because we don't know the value of y in this first example, but we know that because we're dealing with an even root and an even power, we have to have a positive value. Because if we have a negative value, we won't necessarily get the same answer. So that means instead of just this being y to the first, it's going to be the absolute value of y to the first, because we have an even index of an even power with an odd root answer. Well, I should say odd. That looks like 0. Y to the first is odd. All right? Here's another example. The sixth root of 64 times the quantity 2y plus 1 to the 18th. Okay, well, we'll split it up. The sixth root of 64 is 2, so we'll just write the 2. All right? Now notice I don't have to put absolute value bars around this because I know the value. It's 2. I'm making it positive. Now this, I don't know what the value of 2y plus 1 is, but I know using my rule, since it's raised to the power of 18, and I'm taking a sixth root of it, 18 divided by 6 is 3, so I'm going to have 2y plus 1 cubed outside my root. But look at my even, odd rule. Even index of an even power with an odd answer means I've got to actually put an absolute value bar around the expression. Okay? You have a couple more examples of these that I want you to try. You can do that. This is probably the only tricky part of this section, is this idea of when to use absolute values. But your key is this rule. Even, odd. Even index, even underneath the radical, odd answer means absolute values. Okay? If you have any questions, please feel free to ask me. Thanks for watching.